Thunder. Hello, everyone. We are Team Turtle Revolution, and our topic for our research is we are hoping to analyze potential factors affecting prices on different airlines industries among India and US. I'm Henry. So first, I'm gonna introduce our content, general content. So first, we'll make a short introduction about our project. Then we'll introduce our data analysis and pre-processing metrics. Thirdly, we'll talk about how we analyze different factors which are affecting the price on Indian and US airline. On the fifth section, we'll talk about the findings using sentiment analysis among different airlines review. Lastly, we will share some observations on prediction for performances among different modelings on the pricing of airlines ticket. First, I will make a short introduction about our research. Since nowadays the airline industry is considered one of the most sophisticated industry, using complex pricing strategies, ticket price can vary dynamically and significantly around different airline companies. Regarding the supply and demand relationship between airlines and customers, we're curious about finding potential factors that affects the pricing on different airline companies' unrelated flights, from a customer's viewpoint. In general, we'll make a chronological and horizontal comparisons among different airlines to successfully explore the correlation between different factors that impact an airline's pricing strategy and make an accurate prediction on such future prices. Taking a step further, our research is initiated by a current ongoing research, which is focusing on pricing predictions. And here is some conclusion that we are concluded. Now I will introduce our data, the data set that we're used. So first, we're using a airline review data set. It includes two features. One is the airline's name, and the second is the reviews of different airlines. Then we relied on two different data sets, with one resolved for Indian Airlines and the other resolved for the US airline. In total, there are 8 main features that we are focused on, such as airline, stops, and prices, which is our target variables. Here's our data preprocessing metrics. So first, we drop a name columns. Then we're calculating duplicated entries. During our calculation of the percentage of missing values, we surprisingly discovered that there are 0 entries in both datasets that we are relied on, which is really surprising. The fourth, we will outputting unique words from each column in the dataset. In conclusion, since both of the airline datasets is usable without further detailed cleaning, we will just use it as a foundation for our future analysis. Here is some snapshots from our codes. Then our hypothesis and goals. So first, our goals is the primary goals for this project is to unravel the complex factors that influence flights pricing across various airlines. We aim to establish a clear connection between airline pricing strategies and customers' perceptions by analyzing the vast dataset comprising flight options and passenger reviews. Here are some key objectives included. So first, the customer's rating impact pricing, and time and convenience factors, or airline-specific tendencies between like different factors. Now, Leo will introduce the following part.
Hi, I'm Leo. And for the explanatory analysis, we just show the basic information of the dataset by segmented the data into airline companies, classes, and etc. And we also visualize the trend and average prices for each category to see how the variables affect prices. And here is the metrics for our descriptive analysis. So basically, we just use the heat map, histogram, scatter plots, box plot, regression plot, and the robust regression model to provide a more accurate result for the relationship between variables and the target variable price. And here is the histogram for the number of flights in each Indian airline. So we can see that the Vistara airline has the highest number of flights, and the SpiceJet airline has the lowest number of flights. For this Indian dataset, we have around 200,000 economic class and 100,000 business class. And from the box plot, we can see that the business class tickets have higher overall prices than the economic class. From these two scatter plots between price and days left for flights, although we can see there's a drop in price if the departure time is very close, it still follows a relatively linear relationship trend when the departure time gets closer. So this phenomenon might suggest buying tickets early might save money. And here is the histogram for the average price by departure time of the flights. And we can see the flights depart at late night have the lowest average price, and the flights depart at early intervals have similar average price around $250 to $270. And here is the histogram of the average price by arrival time of the flight. And we can see the flights arrive at late night have the lowest average price, and the flights depart at evening intervals have the highest average price. And here's the heat map of average price for each combination of departure and arrival time. If the color is darker, it means that the flight price of this combination of departure and arrival time will be higher. So here are two diagrams that shows the average price for different Indian airlines. So we can see the Vistara airline and Air India have higher average price than other airlines, since only these two airlines have business class. And the Vistara gets the highest average price, following by the Air India, and the Air Asia gets the lowest average price. And here is the box plot for the average price for different number of stops. And the flights with one stop have the highest average price than other. And the flights with zero stop have the lowest average price. And here is the scatter plot and the regression plot between price and flight duration. So if the duration is less than 20, there's an increasing trend in price. And if the duration is larger than 20, there's a decreasing trend in price. And the highest price in the trend is when duration is around 20 to 25 hours. And here is the heat map of average price for each combination of source and destination city. And in the later part, Arthur will talk about the EDA of the US airline.
So I will introduce the EDA of American Airlines. And this is the national flight information counted by the company. So we can see Delta, United, and American Airlines has the most count. And we can see the price difference for different classes. There's around 450K economy class and 1K business class data. And we can see there's a huge price difference between the median of business class and the median of economics class, which is 1,300. And this curve shows how price changed by the date left for flight. The price will be the highest when there's only 40 days left for flight, but will become lowest when there's only 4 days or if there's 60 days left. But when the day is smaller than 3, the price will increase significantly. Yeah, and we can see the average price by the departure time. The flight departure at night have the lowest average price, and the flight departure at the early morning have the highest average price. And the other time, there's no big difference in price. And the average price by the arrival time can be seen in this plot. The flight arrive at afternoon have the lowest average price, and the flight arrive at morning have the highest average price. And based on the heat map, we can see on average, we can see the flight take off at the morning and arrive in the early morning have the highest price. And those flights that take off at early morning and arrive at late early morning have the lowest price. And we can see the price for the different airlines. So Alaska Airline has the highest average price, and the Frontier Airline has the lowest average price. But if we focus on the 3 biggest company, the AA, United, and Delta, we can see Delta has the most expensive price, and AA has the cheapest airline.
So the price of the different stop, you can see if there's two or more stops, the higher it will have the highest average price. And if there's zero stop, it will have the lowest average price. Maybe it's because the number of stop is correlated to longer distance and long duration time. So, and we can see this is the map, this is a graph for the total travel distance and the price. So the price just increased slightly when the total distance increases. However, the duration time change when duration time increases, the price would change is more visible. And the price, you can see this heat map. This is the correlation between this is the heat map of the arriving at departure airport. So the highest average total fare is from Miami to Oakland, and the lowest is from Boston to LaGuardia. The price of the airline in depart and arrive in Oakland and San Francisco is the most expensive, and the price from LaGuardia and Boston has the lowest prices. And then Morgan will introduce the sentiment analysis.
So here is the sentiment analysis part. So I'm gonna first do some general steps. So the first step is to remove the shorthand step stop words and also remove links and also to normalize white space. The second step is to lemmatized the sentence using the air ticket packages. And next is to categorize reviews for different airlines and randomly select 100 representatives. But the most important part is to use the fader package to analyze sentiment of reviews. And finally, we're going to visualize the data for different airlines for the analysis. And this chart is the criteria for leveling different attitudes of reviews. So here is the top words and sentiment analysis. And as you can see, it's basically related with flights or airports, which is pretty reasonable because we're doing sentiment analysis of the flight price. So here is the sentiment analysis result for Indian Airlines. And here's the first two Indian Airlines. Also, we only have 3 Indian Airlines in hand because we can't find other reviews for the other airlines. Well, for this two pie chart, as you can see, the blue part represents the largest proportion of the reviews. And they are both very negative. So it's pretty bad for those 2 airlines. And it's basically saying for the Go First Airlines, which has almost 46% as very negative. So compared with US Airlines, I was saying the US Airlines is generally much better than the Indian Airlines because even though it's basically the same, like the blue part is still very negative, but the proportion is much lower. So the first 2 airlines is American Airlines and Delta Airlines. And it stays same for United Airlines and also Southwest Airlines. The last airline is Alaska. Well, as you can see, it's much better than the previous airlines because the blue part is now very positive and it only has 26 as very negative. So I think it must be related with the price fluctuation here. So talking about the connections between sentiment and explanatory analysis, I think this might show very weak relationship with the price of airlines. Because if one airline company continues to receive almost half reviews labeled negative by all its customers, it is very hard for this company to continue opening. So there must be some problem here. And there is one possible and reasonable assumption that most of those who give feedbacks are the ones who do not really satisfy with the flight journey. In other words, those feel good and nothing understanding about flight journey might not give feedbacks. So based on this assumption, the price might be related with the feedback, which suggests that the potential customers who have not give feedbacks are not feeling good about the price in the whole journey. So to test the correlations of price and reviews further, we need more unbiased data from all customers and not those themselves feeling unsatisfied. So the next part is modeling. Henry gonna do this.
So hello everyone, I'm back again. So I will wrap up our presentation by introducing the modeling setup and our conclusion. So in total, we use 9 models in total for price prediction accounting for different provided features in the dataset. Like there are well-known linear regression regressor, decision tree regressor, ridge regressor, etc., etc. And here's our findings. So for the Indian airline dataset, decision tree regressor and extract tree regressor are two representatives of high accuracy model. And linear regression and badging regressor are two representatives of the low accuracy model. For US airline dataset, high accuracy, like the majority of the model that were used is possess a very high accuracy. And there are only two low accuracy model, which is k-neighbor regressor and linear regressor. The metric that we're used to evaluate the accuracy is based on two values. The first one is MSE and the second one is R-square, which are taught in our class. So here's the modeling analysis that we're conclude out basically just what I've just said on the previous slide. So we'll just skip this slide. In conclusion, our original goal was to predict the flight price ticket based on numerous factors. However, with the experiment and analysis go further, it is very difficult to accurately determine the price, since the price is determined by many various factors, and none of them can be consistent over time. Doing the precise prediction work becomes super hard. But fortunately, we can still expect an expected range for general price based on the given factors. For example, buying ticket early can significantly reduce the price compared to the price of buying approaching departure date. And here's our reference. Here's the reference that our research are based on. And thank you for listening.